Okay, so today we're covering lessons 8.1 and 8.2 because they're very similar. They also start out the chapter talking about proportions. So this lesson is kind of just thrown into this chapter. It really doesn't have anything to do with what we'll be doing to the rest of the chapter, but it's definitely a good skill and a really important skill for taking standardized tests. So 8.1 is all about direct variations in proportions, and 8.2 is about doing inverse and joint proportions. And we're going to go ahead and just do them all at once. So you can see here on the left for direct variations and proportions, it says a linear function of the form y equals mx is called a direct variation. Y varies directly as x, meaning as we make x a bigger and bigger number, y will also become a bigger and bigger number. That constant m is called the constant of variation. When we do our lesson 8.2, we refer to it as k instead of m. It really doesn't matter. You could also call this constant of variation k if you wanted. The reason we don't is for a linear function like this, that coefficient would technically be the slope. So moving on to inverse and joint proportions then, it says over here a function is defined by the equation of the form y equals k over x. That's an inverse variation, meaning as x gets bigger and bigger, you're dividing by a larger number, so y actually gets smaller. So they're inversely proportional. That k there again is called the constant of, in this case, proportionality. It works very similar to the constant of variation. So we're just going to jump right into some examples. So it says example 1, if y varies directly as x, and if y is 10 when x is 2, find y when x is 7. Okay, so it sounds like kind of a lot of information, but here's what's going to happen every time. First, you need to look whether it is a direct proportion or an inverse proportion, so you know which formula to use. In this case, it is a direct proportion, so we're going to use the formula y equals mx. So that's step 1. The second step is they'll always give you enough information to solve for your constant of, in this case, your constant of variation. So it says if y is 10 when x is 2. So if we know, this is step 2 now, we're finding our m. It says y is 10 when x is 2, we'll be able to solve for our m. And in this case, we can do that by just dividing by 2 on both sides, and we'll get that m is 5. The final step then is always to go ahead and find what they're asking for. So it says find y when x is 7. So that's what we'll do here, find y when x is 7. So now you have an equation with m as 5, because that's what we found in step 2. So now you go ahead and put m in, and now you just use the information given. So it says find y when x is 7. So just plug in 7 for x, and you'll get y is 35 for our final answer. Example 2, if y varies inversely with x, and if y is 5 when x is 1, find y when x is 25. Okay, step number 1, decide if it's an inverse proportion or direct proportion. In this case, it's inverse, so we're going to use the formula y equals k over x. Step number 2 is always to find that constant, so we're going to find k, given the second piece of information. So it's when y is 5, x is 1. So when y is 5, x is 1. So that means we can multiply by 1 on both sides, and we'll get that in this case, k is 5. The last step is always to find what they're asking for. So it says find y when x is 25. So let's see here, we're going to have y equals 5 over x, because that's what we found out. Our constant of proportionality is 5. So now we'll find y when x is 25 by plugging in 25 for x, and we'll reduce, and our final answer is 1/5. Example 3, p varies inversely as the square root of q. If P is 12 when Q is 36, find P when Q is 16. Step number 1, decide what equation to use. This says it varies inversely. So we're going to be using what would be y equals k over x, but this time it's not x's and y's. So we need to change that. And also, this time it says it varies inversely as the square root of q. So we need to handle that as well. So it says p varies inversely, so it's going to be k over q. But it's not just inversely to q, it's inversely to the square root of q. So this is the equation that we're going to work with. Now all the steps are the same. Use the second piece of information here. P is 12 when Q is 36 to find K. So P is 12 when Q is 36. So that's 12 equals K over the square root of 36 is 6. And then we'll multiply 6 on both sides and get 72 is K. So now we have the equation P equals 72 over the square root of Q. And we can do the last piece here. Find P when Q is 16. So P equals 72 over the square root of 16, which the square root of 16 is 4, and 72 over 4 is 18. Example 4, if A varies jointly as x and the square of y, but inversely as w, and A equals 2 when x equals 4, y equals 3, and w equals 18, find y when x is 2, A is 1, and w is 36. Okay, so we get this new word jointly in here. Jointly is referring to when we're varying with more than one variable. So you can see how it says A varies jointly as x and the square of y. So A varies jointly as x and the square of y, so y squared, but inversely as w. So we have a direct proportion happening here with x and the square of y, but an inverse with w. Okay, now all the other steps are the same once you write the equation. So we use all this information to get our k. So find k. So we have, let me fix that. A is 2, x is 4, y is 3, and w is 18. So all I did was plug all those values into the equation that we wrote, and now we can solve for k. In the numerator there, we're going to get 9 times 4, so that's 36k over 18. 36 over 18 is just 2, so we get 2 equals 2k, or in this case, k just equals 1. Now the last step, we find what we're asking for here. So this is asking us to find y. So we have A equals, in this time, now we solve for k is just 1. So 1xy squared over w. And now we'll plug in all this new information. So x is 2. We're solving for y. A is 1. And w is 36. So this time we have a little bit of rearranging to get to solve for our y, but that's no problem. First thing I'm going to do is multiply by 36 on both sides, so I'll get 36 equals 2y squared. Dividing by 2 on both sides gives you 18 as y squared, and then taking the square root of both sides gives you plus or minus root 18 equals y. Don't forget to simplify. We know root 18 is going to be plus or minus 3 root 2. Okay, the last thing we need to do is try one of these with a word problem. So it's going to look really wordy, but we're going to just pare it down right away. So it says the electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. 100 meters of wire with 6 millimeters has resistance of 12 ohms, and 80 meters of a wire with the same material has resistance of 55 ohms. Find the diameter of the second wire. Okay, Let's just start making some variables here. Otherwise, there's just way too many words. So let's call the electrical resistance R. What other variables do we have here? We have length. Let's call that L. Diameter, we can call D. Okay, so let's translate that first sentence. It says, the electrical resistance of a wire varies directly as its length. So we know that that's going to go KL. And inversely as the square of its diameter. So inversely means it's in the denominator, and then we're squaring the excuse me, and we're squaring the diameter. Okay, now let's use the next sentence to find our K. That's always step 2, find K. So we have 100 meters of wire with a diameter of 6 has resistance 12. So resistance 12, length 100, diameter 6. And now we can solve, and 6 is being squared. Now we can solve for K. So first thing, I'll multiply by 6 squared on both sides, which we know is 36. So we have 12 times 36 equals K times 100. And then dividing on 100 on both sides, we're going to end up with a decimal here, so we're just going to leave it like that. 4.32 is our K. Now we use the last sentence to find what we're looking for. So first of all, we're trying to find the diameter. Let's plug in all this information. So it says 80 meters of wire, so that's our L. And then what else? Resistance of 15 ohms. Okay, so resistance 15. We just learned that our K is 4.32 times the length of 80 that was given in the problem. And we're trying to solve for our D squared, or just our D. So first thing, to get that out of the diameter, or out of the denominator, I'm going to multiply by D squared on both sides. So I'll get D squared times 15. So 15D squared equals 4.32 times 80. So now I'll divide by 15 on both sides and then take the square root. So I'll get, let me write that out, 4.32 times 80. This is all just algebra now. Take the square root of both sides. So we'll get D equals plus or minus the square root of 4.32 times 80 over 15, which we only want the positive version because we're talking about diameter, can only be positive. So we'll get 4.8. Look for your units. The units of diameter was millimeters. So we're going to put MM. So these word problems look a little scary, but if you just write away all of the variables given to you, if you go ahead and define them as just a letter, it's going to make it look a lot easier. Okay, so this counts as one homework assignment. It's 8.1/8.2, and you can see that on Schoology.